Hello everyone, welcome to my YouTube channel. Today I'll be creating a short and sweet playlist regarding creating a web application using Streamlit. This is an open source app framework. Also, it serves as the fastest way to create data apps. This playlist will be divided into two parts. In first section, we'll be focusing on creating a simple and basic ML model using Iris dataset. We will store this model into Pickle format, and in second part, using that model, we'll design our Streamlit web application in a simplest way possible. After watching this video, I guarantee that you can create your first web application using Streamlit hassle-free. So without wasting any more time, let's get started. In this video, as said, we'll be creating a simple ML model using Iris dataset. This dataset is publicly available on Kaggle. It's a simple dataset consisting of majorly three types of Iris species. We have independent variables such as sepal length, sepal width, petal length, and petal width, and we need to predict the Iris species. So I'll be attaching the link to this dataset in the description below. And now let's jump to the coding part. We will start off by importing our important libraries such as importing pandas, importing numpy, importing sklearn. Sklearn is a simple yet effective library which covers its application in whole data lifecycle. We'll just execute this one. Now we'll import our dataset using pandas.readcsv and the data file which we have saved from Kaggle, and we'll store this in our data frame df. We'll execute this one and we'll just print the data set. You can see we have ID column, we have sepal length centimeter, we have sepal width centimeter, petal length centimeter, and petal width centimeter. And the Iris species, there are majorly three species such as Iris setosa, Iris versicolor, and Iris virginica. So we need to classify between all these three species using these independent variables. Now, as you can see, this ID column is just an increment value that 1, 2, 3, 4, 5. So it's better to drop them since it will not contribute much for predicting our classes. After dropping the ID column, we want to classify our Iris species, and our target variable is categorical. So what we can do is simply use label encoder to label each category uniquely, or we can do manual labeling these target variables. Here I've just labeled them manually. So if our data frame dot species is Iris setosa, it will be labeled as 1. And similarly, if it's Iris versicolor, it will be labeled as 2. And if it's Iris virginica, it will be labeled as 3. We'll just execute this step. Now we'll just print our head. As you can see, our Iris setosa has been labeled as 1. Now to ensure that our data is exclusive of any null values, we'll just execute this command df.isNull.sum. We can see our data doesn't have any null values, because if our data has any null values, it will pop up an error while training phase when we are training our model. Now we'll just simply take our independent variables and store it into X, and we'll take our dependent variables, that is target variable species, into Y. When we execute this df.info, this will give a brief summary of our data frame, that what is the columns, what are the null values, and the data type, and also the memory usage. We can see that our species column, that is our target variable, is an object data type. So now we'll just change that data type from object to integer by executing this command. We will import train test split from sklearn.model selection, and what we'll do is that we'll convert our data set or data frame into test and training set by using the train test split, passing on our x, that is our independent variables, y our target variables, test size as 0.2, that is our test set will be 20% and our training set will be 80%, and we'll give random state as 0. Now our data set will be transformed into xtrain, xtest, xytrain, and ytest. Now, as we are dealing with a simple problem, we'll be only using logistic regression to classify our species, and we'll import accuracy score to evaluate our model from sklearn.metrics. We'll just execute these both commands. Now we'll quickly initialize our logistic regression model and use it for prediction. We'll be passing this xtrain and ytrain, that is our training set, which we had splitted from train test split. We'll execute this. We can see that our model has been built with these default hyperparameters, and now we can use this model for predicting our test set and also evaluate our model using accuracy score by passing our predicted values and our real values. We'll just quickly execute this step. And as you can see, we have got an accuracy around 97%, which is great. But actually achieving this high accuracy is not practical in real world scenarios. But considering the simplicity of the data set, we can always expect this much accuracy. Here comes the last and important step. Basically, we'll be importing joblib from sklearn.externals. Joblib is a set of tools which provides with a lightweight pipelines in Python. And finally, we'll be dumping our logistic regression model LR into Pickle format. We can save our model as Pickle File by keeping the extension .pkl. So any file name you wish to keep, .pkl is the Pickle format. When you execute this, our model has been saved as a Pickle file. Basically, Pickle is used to serialize our ML algorithm and save it in serialized format. We can load this file later to deserialize our model and use this for our new predictions, which basically we'll be doing in next video of this playlist, where we'll be using this LR model, that is logistic regression model, for predictions in our Streamlit web application. Well, this completes our first part of this playlist. We used this iris dataset and created a simple logistic regression model using the same, and finally stored that model into the Pickle file. This was all from my side. If you like my content, please do like, share and subscribe my channel. In the next video, we'll be building our simple web application using Streamlit, which will render our this logistic regression model in the backend and locally host our web application. So thank you so much for watching and stay tuned for the next video.